One. Hello YouTube viewers and subscribers. Justin here, aka Trainman1986, and I want to demonstrate a new signal circuit which I have built homemade for my two BMLA signals here. I'm sorry, BLMA signals. I want to demonstrate the different behavior that this circuit does as far as the lights switching. One of the things I've noticed with real signals is when the light changes from green to red, there's a bit of a delay from the time the green light goes off to the time the red light comes on and the train passes it. So basically what I've done with this circuit is tried to mimic that. So let's go ahead and have a look at the board itself, which is right down here, mounted in a test mode here, test format. Okay, as you can see, it looks pretty complex. I'll try not to go too much into detail to confuse people. We'll say one thing, it took me about 3 days to build. So let me get a better view here. Camera down. Okay. There we go. Alright, so basically this board will drive 4 3-light heads. I got it set up to drive the BLMA light format, or light arrangement, which is what they call the common anode LED arrangement. Some signals I have are common anode and some are common cathode, so by doing a homemade board it allows me to intermix the two and still be able to interconnect them for interoperability. So basically, just a little overview of the board here. We got our power. The board runs off 5 volts DC. So we got our power input here. Up here we've got our outputs, our 4 different outputs for the 3 light heads. And then on this side here we've got the 4 different inputs. Each 3-light driver has a yellow input and a red input, or a detection input. So the yellow input's on the top here and the red input is on the bottom. So by grounding or connecting the input to the negative side of the power, it'll give, if we ground the yellow, it will give a yellow aspect, and grounding the red will give a red aspect. And of course, if you ground the yellow and then ground the red, leaving the yellow ungrounded, the red will always override the yellow. So before I demonstrate the operation of that circuit, I'd like to demonstrate the operation of the older circuits that I build that's a little less prototypical looking. So let's have a look at that. Alright, over here we've got a homemade signal bridge with signal heads added. I custom built this bridge. Had it custom painted by a friend, and then I later added the signal heads. This one is completely wired into the track circuit, the block detection, and also the switch tracks. Right now the block detection should detect. I got a resistive wheel set car on the track, so being that this is a DCC setup, the detector should detect the car. Now if you observe, you'll notice when I roll the car into the block, that green light will immediately change to red. There's almost no delay whatsoever in the operation. I'll pull the car back out of the block. The detector itself has a delay built into it. So once that times out, it should go back to green. Time out any second here. It's taking quite a, there it goes. Okay, taking a little bit of a long delay on that one. So you notice that when it changes from green, or from red back to green, it immediately goes to the color. So almost instantaneously, no delay at all. So at first when I installed the signals, the operation didn't bother me as much, but doing a more prototypical installation now, I want a more prototypical response to it, or more looks. So as I'll show you in the next clip here, we'll demonstrate the new circuit and we'll compare the two and you'll notice the difference. Okay, here we are back to the new circuit. Just for testing purposes, I've got the inputs connected to, I'm using an Atlas selector. Being that there's 8 inputs, I've got eight switches, so I can control the yellow and the red input and basically create any kind of aspect I want on the signal. This is just for testing purposes only. The final circuit will be hooked into an interlocking board, which will take detector input and switch input, switch position input, and then line up the appropriate signal. Alright, so let's move up to the signals here. Try and get a good zoom on these so you can see the difference in the light behavior. Alright, so that left-hand signal, let's do a demonstration as to how that changes. So what I'll do is I'll change one of the switch settings here to where I get a green over red. And if you watch carefully, you'll notice a bit of a delay in between from when the red light goes off and the green light comes on. So a little bit more prototypical looking. Let's go to a yellow, and you notice that it switches, the green light will go off, the yellow light will come on, and I'll leave the yellow aspect on. Now I'll give it a red, and you notice that it does the same thing. It switches immediately, or not immediately, but it changes. There's a delay between the change time. So let's go ahead and demonstrate the bottom head. So we got a red over yellow aspect, or if I turn the yellow aspect off, we get a red over green. And again, same thing. It has that bit of a delay built into it, give it a more prototypical look. Let's go ahead and demonstrate our left-hand signal, or our right-hand signal here. And the same thing, get it clear, light changes from red to green with the delay built in. Let's give it a yellow for an approach, and we'll give it a red input. Now let's test the bottom head. Same thing as the other one. Red over yellow and red over green. So as you can see, the difference in between the two circuits. Looking to employ this on pretty much any new signal installation on the layout. So we'll take a look here at what we're looking at as far as what these signals will be. Here's a look at the track work that these two signals we're demonstrating will show. Pardon me while I move my tripod. We'll turn these back to where they're facing the right way. Alright, so this is actually the upper level of my layout, and as you can see, the yard is below. Lots of train cars in the yard. A bit of a mess. Please excuse the bit of a mess on the layout. I got some cleaning I have to do for sure. So, but on the upper level, I've got basically double track. Comes all the way around. I got a little junction built in here. So what these two signals are going to do is basically govern movement from the double track into the single track, and also into a small industry track here, which you can see diverging off towards the right. Also has the road railer train sitting on it. And over here we got the helix. The track to the left, the main line, is actually the one that begins to descend down. And I'll kind of follow along with the camera here. Let's turn some light on. There we go. this one descends down to the lower level. You also got, here's the track we're just talking about, you also have this track here that's actually opposite, the opposite half of the main. So this track is actually ascending up as this one is descending down. It's kind of a neat arrangement for the helix. So here's the other end of the double track for the upper level. This is actually going to be some signals that are going to get redone and get the new circuitry built for them, like we just demonstrated. So as you can see, in the middle of the helix I got a set of intermediate signals, which are right here. And I also have a lift open bridge to walk in with a little bit of scenery involved. So my plan is to remove these intermediates and re-signal part of the helix here, so a lot more of my signals are within view. A lot of the signals like this one here and this one here you really can't see if you're in the main operating pit. So the goal is to re-signal a little bit to make signals more viewable and thus more enjoyable to watch. So again, here's our track we were following before. It comes down over the bridge and then continues to descend all the way down, way behind the helix here. Kind of hard to see, here it is. And then to the lower level and into the yard. And as you can see, that's that homemade signal bridge we were looking at before. So which is also going to get new circuitry built for it. So just a bit of a overview on the layout portion. And again, I'll do another video showing the signaling once I get that section of track complete. So, but let's have a look at the newest board I'm working on and also the new BLMA signal I built. Okay, here's a look at the new board I'm currently working on. I got probably about 80% of it done. I'm going to finish it another day, so I got some time to troubleshoot or work out any problems, may there be any. And then the signal it's going to drive is this guy right here. My custom made 3-head BLMA model signal. I custom made this out of 3 single head signals, and I have to say I'm impressed with the results I got. So not too bad for first time converting or kit bashing one of these signals. They're a bit delicate, but if you're careful enough, you can make them work. I just used some aluminum tube you can pick up at most of your hobby shops, and use some super glue very carefully to glue it all together. So, and as you can see, this board here only has 3 outputs, so this will drive 3 light heads, and it's going to be basically the same setup. You're going to have your yellow in and your detection for each head, and by putting by any combination of inputs, you can get any aspect of basically any rule book you want, depending on your input logic. So that's a project for another day, and once I get that complete, I will do a demonstration of that as well. So, alright folks, here's a demonstration of the 3-head BLMA model signal that I custom made. Just got the circuit board finished today and also worked out a few of the bugs. Seems there's always bugs post-construction of any homemade circuit board that need to be worked out. So just want to give you an overview of what I got set up here. This is basically a test setup. So here's a look at the board, the finished board itself. And you notice that it's got your 3 inputs for each 3-light driver, and then your 3 outputs for each 3-light driver. So as you can see, 3 inputs, 3 drivers, 1 for each head. And here's a little bit of a close-up of the 3-head signal, the custom-made signal I built. So, and then for testing purposes today, I got it set up that the input's wired. I'm using a couple of Atlas connector switches that we'll use to simulate different inputs, different yellow input and detection inputs to control what aspects we get. So starting over here, I got the top head. These two switches are going to control the yellow and red input of the top head. These two, the last switch and this switch here, are going to control the middle head. And the switches all the way to the left here are going to control the bottom head. Now, as you can see, if you look closely, I've got the reds turned on. So the red input on the board is actually active, thus giving the aspect you see here. So if I turn the red aspect off, I will get a green. And as you notice, it's got that delay built into it, giving a realistic color change on the signal head. So let's go ahead and demonstrate just the operation of the circuit itself and create some aspects. Alright, so we got a high green, we got a clear, and I'll name the aspects in according to the speed signaling, which I'll be employing on my layout. Actually, I'll be using NORAC rules, which are more common this area of the U.S. that I live in, which is Michigan. So I know down the Detroit area they use a lot of NORAC aspects. So kind of what I'm modeling. So I'll basically be demonstrating those. But obviously you can, with the input logic, you can create any kind of aspect you want. You can create route signaling, speed signaling, any kind of rule book you want, basically. Alright, so we'll start off with a clear. And let's give ourselves an approach. So we'll activate the yellow input on the top head. And let's give ourselves, we'll give ourselves an approach medium. Get the right switch here. An approach medium. Let's go ahead and activate that red again. There we go. Oh, now actually we got an approach slow, yellow over yellow. So go ahead and ground that out. Okay, let's go ahead and give it red. Let's give a medium clear. So there's a medium clear. And medium approach. Let's see. Well, actually, we'll flip it back to medium approach. Let's do a medium approach medium. Red over yellow over green. Let's go ahead and flip that. Now, actually, that would actually be a medium approach for, I believe, CNO aspects. That's an interesting one. Let's go ahead and put it back to medium approach. And in fact, let's actually go ahead and bring everything back to red. There's a slow clear. I would do a slow approach for NORAC, but being that I don't have the board set up to flash the aspects, this is actually a restricting, rather. I believe on some railroads, though, this would be a slow approach. So, but the board can easily be modified. I took this into account when I built the board. It can easily be modified. If I add in extra circuitry, I can flash any of the aspects. So I could flash the red, flash the green, yellow, any particular aspect I want, just by adding in a little bit of circuitry, which I might add on at a later date, but I think for now I'm just going to have steady aspects. So that's an overview of the 3-light BLMA model signal that I've custom built, and looking to employ this on the layout here at some point, and when I do, I'll make a demonstration video of that. So hope you enjoyed this little introduction to my signaling, and feel free to comment and subscribe if you will. Thank you very much. Have a good day.